Hello, welcome to Astronautics for Exploit. This is Dr. Ayenshola Ogundele. The next generation of spacecraft ground segment, defined by increasing automation, cloud-based infrastructure, and enhanced flexibility. Spacecraft ground segment, Earth-based infrastructure of antennas, networks, and control centers that communicate with and operates a spacecraft and responsible for sending commands to the satellite and receiving data such as telemetry, scientific measurements, and images, which are then processed, distributed, and made available to users, is evolving day by day. Ground station segment is made up of ground tracking stations, terrestrial stations with antennas for transmitting and receiving signals to and from the spacecraft, communication networks that connect the ground stations and control centers, operations control center, a central facility where mission control teams monitor and command the spacecraft, data centers, facilities with computer hardware and software for processing, storing and distributing data, and flight control team, the personnel, including engineers and analysts, who are responsible for managing the ground segment and the mission. The next generation of spacecraft ground segments is defined by increasing automation, cloud-based infrastructure, and enhanced flexibility. The major characteristics of next-generation ground systems are cloud-based virtualization, software-defined and interoperable systems, high throughput, and flexible communications. Next-generation systems are being designed to be able to switch dynamically between different orbits, such as low Earth orbit and geostationary Earth orbit, and frequency bands in order to ensure seamless connectivity. The focus points are as follows: drivers behind the shift to next generation systems, major characteristics and technology advancements of next generation ground systems, examples of next generation ground segments, and the future of spacecraft ground segment. Drivers behind the shift to next generation spacecraft ground systems. The drivers are as follows: proliferation of satellites, the increase in small satellites, mega constellations, and multi-orbit missions, low Earth orbit, medium Earth orbit, and geostationary Earth orbit, creates unprecedented data volumes and operational complexity. Cost reduction. The push to lower mission costs drive the adoption of cheaper, more efficient commercial off-the-shelf hardware and the OPX operation expenses based on ground station as a service model. Low Earth orbit constellation is illustrated in this picture. Increased data demand is another driver. Higher resolution imagery and new applications such as Internet of Things require a more robust and scalable ground infrastructure in order to handle greater data loads. LEO satellite constellations Starlink, OneWeb, Upcom, and Iridium are illustrated in this picture. Ground-based infrastructure, resilience and security. Growing international tensions make resilience and cybersecurity critical. Virtually distributed and artificial intelligence-enabled systems are inherently more robust and can be updated more frequently. Interoperability. Integration with terrestrial 5G networks and other communication systems is driving the space industry towards common open standards. Galileo ground segment is illustrated in this picture. Major characteristics and technological advancements of next generation ground segments. The characteristics are as follows: software-defined ground stations. Instead of relying on proprietary hardware, next generation ground systems convert analog radio signals into digital streams and process them with software. Software-defined ground systems can dynamically adjust their configuration in order to support changing satellite requirements, such as adjusting beam coverage or power. Satellite Earth Station is illustrated in this picture. Software-defined ground stations approach is supported by common open standards, especially those promoted by the DV consortium, which enable seamless integration and avoid vendor locking. Software-defined radios and radio frequency over Internet Protocol enable digitization and transport of RF signals over standard IP networks, simplifying ground infrastructure. Ground data systems and mission operations is illustrated in this picture. Cloud-based infrastructure and virtualization is another major characteristic and technology advancement of next-generation ground segment. Ground segment functions are moving from physical, on-premises infrastructure to the cloud, allowing for greater efficiency, scalability, and flexibility. Virtualizing the ground segment separates software functions from hardware, enabling automated scaling and efficient resource management using commercial off-the-shelf parts. The transition to a cloud-based model shifts the financial burden from capital expenditure to a more flexible operational expenditure, and this thereby lower the upfront cost of establishing new services. Spacecraft Mission Control Center is illustrated in this picture. High throughput and flexible communications. To handle rapid growth of non-geostationary orbit constellations, ground systems are incorporating phased array antennas which can track and communicate with multiple satellites simultaneously without mechanical movement. New technologies like optical or laser communications are being developed in order to support significantly higher data rates and enhance security. Next generation systems must be able to switch dynamically between different orbits and frequency bands in order to ensure seamless connectivity. Copernicus ground segment is illustrated in this picture. Artificial autonomy and artificial intelligence. Artificial intelligence and machine learning are very critical for managing increasing complexity of large constellations. AI-driven automation handles routine tasks and processes vast quantities of data, freeing human operators to focus on more complex issues. Select ground segment facilities worldwide is shown in this picture. Ground segment as a service. Inspired by the cloud computing model, ground station as a service allows satellite operators to purchase ground services on a pay-per-use basis. This approach reduces the need for heavy upfront investment in ground infrastructure and offers flexibility to scale operations up or down as necessary. This brings satellite model lowers barriers to entry and accelerates innovation in the space industry. Traditional versus ground station as a service model is illustrated in this picture. Advanced antenna technology. New and evolving antenna technology is vital for handling the complexity of modern missions. Fixed array antennas. These electronically steered antennas can track multiple satellites simultaneously without mechanical movement. And optical communications, laser-based communications, and emerging technology, which offers significantly higher data rates. Network topology of a satellite command and control system is shown in this picture. Examples of next-generation ground segments are as follows. NASA's Near-Earth Network Launch Communication Segment aims to be more cost-efficient as a result of leveraging commercial technologies and remote operations for future space exploration. General Dynamics Space Network Ground Segment Sustainment aims to modernize a critical space network by incorporating modern technology and a more sustainable approach. Integrated ground segment is shown in this picture. ST Engineering iDirect's Intuition is a platform designed to help satellite operators overcome challenges with virtualization, multi-orbit support, and network convergence. Control Center at NASA's Jet Propulsion Lab is illustrated in this picture. The future of spacecraft ground segment. The development of next-generation ground segment is an ongoing process driven by a rapidly evolving space industry. Future advancements focus are on multi-orbit networks. Ground systems must seamlessly integrate with satellites across different orbits. The picture here illustrates Novo Space ground segment. Future advancements focus are also on 5G integration. The development of space-based 5G networks will lead to tighter integration between satellite and terrestrial networks. Quantum communication. Though it is still in its infancy, quantum communication can enable new levels of security and private satellite communication in the future. Satellite ground station is illustrated in this picture. For more information, contact Astronautics for Exploits. You've been listening to the next generation of spacecraft ground segment, defined by increasing automation, cloud-based infrastructure and enhanced flexibility by Dr. Anshola Ogundele, with focus point, drivers behind the shift to next generation systems, major characteristics and technological advancements of next generation system, examples of next generation ground segments, and the future of spacecraft ground segment. Thank you.